Hey everybody, and welcome back to Radical Slice. My name is Eric. You are joining me on part 14, I think we're at, of my ever expanding quest to implement something that looks a little bit like Kung Fu on the NES or Spartan X if you play the Japanese version. This is a nice short episode. We're just going to add a couple of features. First, we're going to wrap up the sort of exploding baddie graphical effect that we began in the last episode, where when you punch or kick any of the plant life, they turn into little pieces of themselves. And then finally, we're going to add a boss health bar, which is a nice, simple change. So you can just kick back, I almost said grab some pancakes. Maybe because it's early here and I'm hungry. Grab some pancakes and enjoy the show. I think the next thing that makes sense to do, since we've already sort of exploded the tree into little bits, would be to also explode these other fellas, and probably the apples too. These folks are pretty small, so I don't know if I want to go with like 5 bits for each of them. Probably just do like 3. And then just add the same logic into the bits thing. So I'm going to reuse the Baddie Manager's bit structure, and the same logic should be okay. It's basically just like using different sprite indexes based on the Baddie type, or if it's the projectile or whatever. So yeah, let me draw some pieces, and I'll get right back to you here. So this is like somewhat interesting, maybe, but I kind of have these top level tables for each of the type of things that I want to turn into bits. Um, but because we now have the baddie type thing, I think what I could probably get away with is basically just have kind of like this top level bits thing. Maybe we'll call it baddie bits. And then index it by table or by baddie type rather. I think that'll work. I'm gonna give this a try and see if I can make it work. So basically, what I want to do is like um, just do an add, or rather, right now I'm explicitly iterating over the tree bits. But I think what I can do is rather just do like for each, and then bits, and then index by baddie type, like this. That way I only have to, I can like reduce the amount of logic I need to write. Because the baddies type will either be tree or wisp or flower or whatever. So if I have a structure like this, hopefully Lua will be smart enough to do that for me. Or maybe not smart enough, maybe loose enough to do that for me. Let me give it a try and see what happens. Okay, that worked beautifully. Let me show you kind of how that played out. So in the collision function, whenever there's a collision with a player and a baddie, I'm just checking this big baddie bits, big old baddie bits table, and I'm indexing by the baddie type, which is either going to be the string value tree or flower or wisp. Let me mark this here, which should give us like this, an index into this table. So I can just, because these each have their own like length and different sprites, as long as I index by the baddie type, this sort of function, this iteration here in the for each will only run for the number of bits that I have for each type of baddie, right? So just to go back to Pico-8 real quick, you can see for the tree, remember we had like 5 different bits. And then for the wisp, I only added these 3. And for the flower, I only added these 3, which means that as long as we keep the entries in our tables to be just the number of sprites that we created, that iterator will only run that number of times and only add that number of bits. And everything else is the same, right? I'm just adding different sprites depending on which type of baddie it is. But all the velocity stuff, the gravity, all that stuff, I kept the same for the different types. And it looks pretty good. Hold up here. I also altered the level a little bit so that the 3 enemy types would all show up right away. So no surprises there. You can see the trees died pretty easy. And then we got a wisp and a flower. and they each break into their respective bits. I haven't done the apple yet. That should be pretty straightforward though, because if we have a look at the code here, the sort of projectile collision code, which is where the apples live, is totally separate from the baddie collision code. So I'd probably just add like the same logic here. Let me just do that right now, actually. So one thing that's interesting is I initially had done this, thinking that because I was indexing into baddie bits with a string of the baddie type before, that it would work like this, but Lua did not like that. It did not work. So I just went baddie bits.apple because we look at the top here. This is how it's defined. So I couldn't just use like the apple string literal to index into this. But otherwise, the code was the same. I just had to change like a couple of B's into the letter P. And it looks like if we go back to Pico-8, it'll look like the way I want it to look. Do this. Cool. Yeah. And I played through this once already and tested bosses in both directions to make sure that there wasn't anything funky about the way the bits would fly out. Man, that one went real far. So yeah, I'm pretty stoked about how this turned out. I guess I could do the same thing for the boss, but maybe, yeah, maybe I should add some bits for the boss. Maybe it would be cool to have that too. Let me draw those real quick. Hold on. So I did the same idea for the boss spread. I just kind of copied and pasted in little pieces of them, made some slight edits. So I've got, the top part, the eyes. I took a leg, I put an arm, and they're not really arranged nicely in the spreadsheet, but whatever. It doesn't matter for right now, I guess. And I added that to the table up here so that we have a boss entry like this. One thing that I did do a little bit differently is I included, you'll see the number 79 is doubled. 79 is this top part of the tree with the leaves and the apples. I thought like it would be cool because it's such a larger sprite to have this like duplicated. So I just did that twice. It would be cooler if I like created a more elaborate data structure and I was like flipping it in different directions and stuff, but I'm not gonna sweat that for right now, I don't think. I guess I could do that with Rand as well. But in any case, what this ends up looking like when we spawn it is, again, not particularly different. Just looking at baddiebits.boss, iterating over that. I did decrease the initial X velocity because usually like when you're fighting the boss, you're usually up against the side of the screen. And so I didn't want to just like have you kick all the pieces right off the screen. I wanted them to stay visible. And so, yeah, I just reduced the initial X velocity a little bit so that I could be pretty sure that no matter where you kill the boss, that you would still see the pieces of it flying all over the place. So yeah, what this looks like is just like that. So yeah, that works pretty well. All right, I think we can call the bits and pieces functionality or visual effect or whatever good for now. We've got all the enemies covered, we got the boss covered, we got the projectiles covered. So that's pretty solid. So we're drawing the player's health to the screen, but the other sort of entity in our game that has health is the boss, and we're not drawing the boss's health to the screen, which I think is kind of problematic. It would be cool if it was obvious like how much further you had to go before the boss died, because especially because across levels, like the boss has different amounts of health. So what I'll do is probably I'll just draw it to the screen if the boss is also on screen. So I'll just have to check in the main game loop, like if the boss is not nil, then draw this thing. And I'll use similar logic to the player's health. I'll just use like a rectangle and I'll draw it based on like it'll draw fractionally based on the baddie's current health or the boss's current health. I guess like the one thing that will be different is that the boss doesn't have the concept of like max health. Like the player, I think we're drawing this rectangle based on the value of 100, right? The player's health bar. Whereas the boss, we set an initial value for the health, like 3 or 5, but we don't actually track like what what it is at the maximum point, like what full health is for the boss. So we might have to add an attribute to the boss entity in order to make this work the same way. But otherwise, it should be pretty trivial. I'll use a different sprite. Obviously, I don't want to have the player's head for the boss energy. So I'll do a different sprite and like a different color. And I'll add that max health attribute. And that should cover us, I think. All right, so I'm drawing a few versions of the life bar to the screen so that we can just kind of see how it's gonna look. So notice like there's no boss on screen right now, so I'm sort of just like forcing it to draw anyway. And I'm using a similar visual to the player's health bar. You get a little icon for the boss guy. I just copied his face and tweaked it a little bit. He looks kind of adorable though, because the mouth is higher in this one. And in order to just like test my logic for drawing the health bar, I'm drawing 3 different versions of the screen when the boss is at 1/3 health, 2/3 health, and full health. And so like I just wanted to see that they lined up correctly or that they looked like the right percentages in code. So kind of what I'm doing, I'll replace this part with the boss's health in a minute. But so this would be like, this is the wrong syntax, but boss.health over boss.max health. So that'll give us the percentage of the boss's current health, multiplying that by 50 so that it scales to the size of that health bar. And that should pretty much do the trick. So let me just uncomment that upper part now and do it. You can see here, like I have to comment out the Baddie Manager boss because this is currently nil. So now that we know that the health bar graphics kind of line up the way we want them to, let's uncomment all this stuff so that it only shows up when the boss is actually on screen. Okay, it showed up when I wanted it to. That's good. So as I hit him, hopefully the size of that bar will decrease. Let me make Pico-8 bigger here so we can watch it together. Oh, we backed up. Bam, bam. Okay, that looked pretty good. That also looks pretty good. And then one more. Great. Okay, so for some reason it's still showing up. Maybe that's okay. Maybe I don't mind if it shows up towards the end of the level. That technically I think that's a bug, but maybe we can make it into a feature. What I'm worried about is when I go to the next level, will it still show up or will it disappear? Let's see. Oh, it disappears. Okay, well that's pretty good then. Let's just leave it like that. We'll call that bug a feature. All right, cool. So that takes care of displaying the boss's health. Oh, actually, let me try against this boss too. Hold on. Because as we know, this boss has 5 health, not 3. As we definitely remember from several episodes ago. Okay, so now this is much harder. Okay, that looked good though. So we would expect to lose about 20% of the health bar with every hit. You're getting better at this. All right, looks good. Looks great. Okay, cool. Yeah, so as I started to say, I think that does take care of drawing the boss's health bar. Get rid of these comments here. Cool, pretty happy with that. Thank you again for your time and attention. I hope that this short entry into the series was a nice break from the 20 and 30-minute epics that have been going up recently. If you had any questions or any feedback, the comment box is always there. And like I said last week, I only get like 1 or 2 a week on a good week. So, I read them all. Your voice will be heard. I promise. So yeah, use that power wisely, by the way. Anyway, I hope whatever you're working on or whatever you're playing, that you're enjoying yourself and having a great time. And I will see you all next week. Bye for now.